There's a certain FOMO gripping the tech industry right now, and it's no stretch of the imagination where it comes from. We've been hit every couple of weeks with some new paradigm shifting advancement in technology that threatens to render obsolete everything that came before it. The pressure to stay on the bleeding edge of the AI adoption curve is as ever present as the air that we breathe. And it's not just for the uninitiated either. Recently, Karpathy, who's one of the most well-respected voices and educators in data science, posted on Twitter saying that he's never felt this left behind before as a programmer. Now, obviously, you would be foolish to disregard anything that this man says regarding this domain, but recently I've found myself questioning to what extent I need to be aggressively adopting every new thing versus more continuing education and more evergreen principles such as productivity, time management, and communication. And I've recently started to lean more towards the latter. And a big turning point for me was when I decided to revisit one of my favorite books this week, known as The Goal. And it was written by Goldratt in 1984. And the reason I was drawn to this book was because I've been having a specific problem at work that I just felt like The Goal would help with, but I wasn't ready for the revelation that it gave me. And I dare say that it's one of the most impactful aha moments that I've ever had with working with AI. And I wanted to share it with you and hopefully inspire you to read the book yourself. And so I'm going to spend the next few minutes describing some of the principles from the book in an effort to do that. So who was Goldratt and why should we care about his book? Well, in order to care about anyone, you first have to know their origin story, right? So that's where we'll start. In a chicken coop factory in the 1970s. Now, Goldratt was an Israeli physician by trade, but he had a friend who had a chicken coop manufacturing factory, and it wasn't going very well. His friend had no trouble getting orders, but they were getting hung up in the factory, and he didn't have enough time to get them out on time, and he was worried that the factory was going to fail. So he asked Goldratt to take a look. And what he found when he looked was that there were inefficiencies everywhere, but they were based on the best practices of manufacturing of the day. And Goldratt, ever the pragmatist, decided to look at things from first principles, and he became really inspired by people in the field such as Henry Ford and Taiichi Ohno, who is the godfather of the lean manufacturing system, and who also took Toyota from a struggling manufacturer to one of the most efficient car manufacturers in history. And through applying these principles, Goldratt was able to turn the chicken coop factory into a highly profitable anomaly. And this created an entirely new career for him. He built a software that he sold to other factories in hopes of giving them the same benefits. But they weren't getting the results that he knew that they could. And as is the truth with every insight that doesn't reach adoption, he knew that it was a knowledge gap. And so he wrote a textbook cleverly disguised as a really engaging and fun read to help people learn the principles that would enable them to get these benefits. And thus The Goal was born. And the story follows Alex Rogo, who's a young but ambitious new plant manager for a manufacturing plant that's really, really struggling. And he's recently been told that he's only got 3 months to turn the plant around or it's going to be closed. It actually also goes surprisingly in depth on the marital troubles that he has from working so much at the plant, which ends up being a really satisfying and informative case study on work-life balance. But that's just a side quest. The turning point happens when Alex is on a business trip and he runs into an old college physics professor named Jonah, who's basically like a Yoda figure. And Jonah starts asking him questions through the Socratic method to help him understand what's going wrong with his plant. And everything seems to hinge around this concept of bottlenecks. And this is where things get really interesting if you work with tools like Cursor, Claude Code, or Copilot. Because if you think about it, modern agentic workflows are surprisingly similar to assembly lines. Allow me to explain. A manufacturing plant has orders to fill. Knowledge workers have JIRA tickets. The plant has a combination of human and machine that both are able to work semi-independently of each other. Thanks to AI, we now have the same. When products or parts are sitting in a warehouse or flowing through the factory, they're known as inventory. Specifically, when they're flowing through the factory, they're known as work in progress inventory. And so it is with unstarted and in progress tickets. And then the cost to run the plant is the cost to pay the employees and to run the machines. That is known as operating expense. And that is the same with human employee salaries and agentic tokens. And the rate at which product flows through the factory and becomes finished products is known as throughput. And the SaaS equivalent is completed tickets that hopefully will lead to increased sales for the company. And that just leaves one more key term to define, and that is, of course, the bottlenecks. In a manufacturing plant, a bottleneck is a slower machine where inventory accumulates in front of it. For Cursor, Claude, and Copilot, those are like your faster machines in the factory, and the bottleneck is you. And what makes this book so revolutionary for thinking about optimizing your work with AI is that it's all around how to optimize the entire plant around the bottleneck. And the goal is to increase throughput by simultaneously decreasing inventory and decreasing operating expense. Think about that in the context of your work. What if you could increase the number of tickets that you were able to complete while simultaneously reducing your inventory of backlog work and reducing your token costs and the cognitive load on your brain? What would that do for how you felt about your work? What would that do for your career? And there are 3 simple principles that I think really drive home the impact here. So I'm going to take a minute to explain those. The first is that flow should be equal to market demand, not equal to the full capacity of the plant. Violating this results in an excess of finished products you can't sell and being behind on critical orders that are stuck behind the bottlenecks. And this one is particularly interesting to me because I work with salespeople, and if you work with salespeople, you know that everything is urgent all the time. I frequently have to drop one urgent task to pick up another, which can make working through things in a fixed order difficult. And what makes things worse is that sometimes I'll spend a lot of time working on something, and then the stakeholder will have moved on to something else by the time I finish, which ends up wasting a lot of time. And for me personally, this has been really exacerbated by AI because of the illusion of added capacity. I find myself taking on all comers, and I just end up with 7 to 10 open cursor chats at any given point in time, which causes me to constantly have to get back up to speed with each one before I can make a decision about what it needs and then send it off again. My logic was AI equals more and faster equals better, right? The characters in this book made that same mistake at the beginning, proving that Americans have been obsessed with the hustle culture since at least the 80s. And this was written in the 80s when robots were just coming into factories and the robots were expensive and they could do things on their own. And so they wanted to run them all the time to get their money's worth. Does that sound familiar? There's only one problem with this, but it's a big one. The book clearly states that a plant that has all of its machines running at full capacity is very inefficient. Why? Because of the bottlenecks. The rule is the capacity of the plant is not equal to the capacity of the fastest machine, but to the bottleneck. If a non-bottleneck machine turns out a bunch of parts because it's running all the time, that doesn't result in more finished products. That results in a bigger backlog in front of the bottleneck. Apply this to working with Cursor. My 7 to 10 chats didn't make me complete work faster. They just piled up a ton of things for me to read through and decide on, which made me have to spend a lot of time digesting and trying to get caught up to speed and then decisioning and then sending them off again. To make matters worse, humans aren't wired for constant context hopping, and so it actually results in something that Boston Consulting Group has termed AI brain fry, where you have this feeling of general fog and you have trouble making decisions because you're doing something that the human brain just isn't designed to do. You need to protect your ability to focus. And so what I've done is actually implemented a strict 3 work in progress ticket maximum. And I've built in a rule that doesn't allow me to spin up any more than 3. So if I want to work on something else, I have to close out or pause whatever I'm working on now in one of my 3 open slots. And if that sounds scary to you, then make sure to subscribe, because next week I'm going to go through exactly how I offloaded the context for each ticket back into Jira so that as I'm working in Cursor, it's automatically writing things back up to Jira so that the tickets stay updated, including blockers and different stakeholders that might need to sign off or things that are pending, so that if I need to close that ticket out to open up a new one, then I can just close it and I know that it's going to pick me right back up where I left off the next time I start it. So nothing falls through the cracks. And that leads us to principle number 2. Quality control should go before the bottlenecks instead of after. This one's so obvious, but it's often overlooked in practice. The book, they realized that most of their quality control happened at the end of the process during final assembly. But by that point, if they found a defective part or a product that had gotten disfigured during manufacturing, they had already wasted the time of it moving through the slow bottleneck. And obviously the AI application is to spend more time defining what you're building and why it needs to be built before you spend the cognitive energy to build it. And I know I've been guilty, especially with AI, of having the easy button where a leader might ask you for something. It seems straightforward enough. So you just kick off an agent and then you start to kind of work your way through it. And I've even got to the point where I've pushed code to production before even asking myself, why did I build this? Did we already have something in existence that could have just been lightly tweaked to get to the same outcome? Did I ask the leader what problem this was solving or why it needed to be built in the first place? And I realized that if I would have taken the time to just ask those few questions, I could have saved a lot of time and avoided straining the bottleneck, which is me. And the last principle is similar to this. And it seems counterintuitive until you look at it through the perspective of a factory. Principle number 3 is reduce batch sizes. So imagine you have a factory and you have a batch of 1,000 identical parts, and they need to go through machine A and then through machine B. And the machine can process at around the rate of 500 parts per 30 minutes. So you run the batch of 1,000 through machine A, which takes an hour, and then you take that same batch and you run it through machine B, which takes another hour, for a total of 2 hours. Now cut that batch in half. You run 500 through machine A, it gets through the 500 in 30 minutes, and then you start it in machine B and simultaneously start the second batch of 500 into machine A and then through machine B for a total operating time of 90 minutes. That's a 25% reduction in time just by cutting the batch sizes in half. And the application for AI is actually really interesting here. I'm one that previously I liked to have one chat where I would work on 5 or 6 tickets so that I could hold the context from each one and just have it grow and grow and grow. But what you'll notice is that AI, especially AIs like Cursor, will use something called cache reads, where they store a lot of the generated outputs in a table so that they can reference them, which saves you on future generations. But as that gets bigger and bigger, they're bringing in all of these cache reads into the full context window every time they run a new chat. And so your chats actually get exponentially more expensive the longer that they get. And since I've offloaded my context back into Jira where I have things automatically writing back up, now I like to keep things really atomic. Whereas I just like to be working on one chat per Jira ticket. And it seems like you would be moving slower this way, but it actually is the opposite. And it saves me that AI brain fry because I'm only managing 3 things at once. And each thing is atomic in that it's self-sufficient and it brings value on its own. This prevents a buildup of bad inventory and it optimizes your bottleneck. So there it is. You have a 376-page book distilled into a couple-minute video. Remember, speed means nothing without taste and discernment. And if you apply these principles of working on the most important things at a pace that's optimized for your all too human attention span, you'll actually get more done and reduce AI brain fog and token costs. And if you like learning about Evergreen principles from great minds of the past, then consider subscribing, and I'll see you next week.